Hello, we, the students of Adams University, Kolkata, have recently completed our work on cloud-based smart application, and this presentation is regarding the same. This is to be presented in 22nd International Conference on Intelligent Systems Design and Applications. In the subsequent 8 to 10 minutes, I'm going to brief you about our work. So let's get started. Firstly, this is the outline of our paper. It starts with introduction and goes up to conclusion, references with all this in the middle. We will go through each one of them one by one. Firstly, introduction. What is cloud computing? Simply, we can say cloud computing is the delivery of computing services including servers, storage, databases, networking, software, analytics, and intelligence over the internet to offer faster innovation, flexible resources, and economics of scale. This research aims to perform academics about the importance of cloud computing in IoT and why these two are inexorably intertwined. Our proposed work is that we have discussed on how data protection, data integrity, confidentiality, authentication, and verification have become more essential as cloud computing and IoT based smart applications have grown. We have reviewed previous 10 years paper in this regard and have investigated the application of cloud of things technology to discover the complementing characteristics of a unique environment from the primary drivers for the future internet. Secondly, what is IoT? As we know that IoT stands for Internet of Things, which is a technology which allows us to add a device to an inert object, say vehicles, roofs, etc., that can measure environmental parameters, generate associated data, and transmit them through a communication network. Some common examples of IoT enabled products are smart TVs, smart watches, etc. Talking in large scale, we have home automation smart TVs, which can be made using IoT technology. Now coming to overview of cloud computing. We have three components as depicted in the figure. Firstly, software as a service, SaaS. This illustrates the software model as a service provider that is more accessible to the clients via the internet. It allows users to use a variety of remote application operating systems and resources without having to install, upgrade, or purchase them. Examples are Dropbox, Hotmail, Yahoo Mail, Cisco, Webex, etc. Next is Platform as a Service, PaaS. This service provides technical assistance for building application without the need for the client to download and install any software. It offers utility design, enhancement, and website hosting services. Collaboration, online service integration, database integration are some of the features. Few examples are AWS Elastic, Beanstalk, OpenShift, Heroku, etc. Thirdly, we have infrastructure as a service, IaaS. This distribution of virtualized network and resource is handled by this service model. Customers can use IaaS to build their own virtual cluster on which to deploy, control, and run their own software stack. For example, Amazon EC2, Google Cloud, Microsoft Azure, etc. Next, let's talk about cloud-based smart application. In this section, we have discussed about quite a lot applications. Some of them as visible are intelligent transport system, fog computing, green computing, smart battery management, healthcare monitoring, smart home, smart city, smart agriculture, etc. Among these applications, let's look into green computing. In IoT green computing as depicted in the figure, it supports IoT system which absorbs lower energy while managing their activities. Green computing focuses on maintaining computing capability while reducing energy use and being environmental beneficial. Now, the most important discussion: what is the relationship between IoT and cloud computing? Cloud computing and IoT both focus to enhance the efficiency of ordinary cores. IoT generates a lot of data, but cloud computing makes it possible for that data to travel. Many cloud providers take advantage of this to offer a pay-per-use model in which consumers only pay for the resources they utilize. In addition, cloud hosting as a service delivers value to IoT firms by reducing overall costs through economies of scale. Therefore, we can say that both are interlinked. So the most acquired data is processed and analyzed on the cloud. It may be stated that the cloud is the brain of most of the IoT. This is the point where IoT and cloud computing interact with each other and work hand in hand. This is the architecture of cloud-based Internet of Things, which we can say cloud of things. We have the IoT architecture layers: sensing layer, network layer, application layer. On top of it, we have the features which cloud give us. On sensing layer, we have data sensing and collection protocols which incorporate upon it the cameras, RFID tags, intelligent sensors. Coming to network layer, there is a cloud. Obviously, coming to application protocols, few applications are smart grid, smart environment, which has their own benefits. There is VANETs, e-healthcare, having further benefits of its own. Next, in this section of literature survey, we have listed out few papers out of our last 10 years paper that we have reviewed. We have mentioned the paper title, the name of the author, and their objective. The first paper is a literature review on cloud-based smart transport system, which is done by our Madam Gulfishan Mobin, and this was her objective. Next, we have papers on smart cities, on a driver monitoring system, on cloud computing and IoT. Further, we have reviewed a paper on survey of IoT and cloud computing for healthcare. There is an automated toll tax collection system using cloud database paper. There's a paper on fog computing, and lastly, role of edge computing in IoT. These were their authors and their objectives simultaneously. Next, the challenges that we are going to face. Firstly, the security and privacy. Now, we all know to establish relevant authorization method and integrity while ensuring that only authorized users have access to sensitive data is in fact a vital question that has not yet been resolved, right? Now, this is important when it comes to protecting users' privacy, especially when data integrity is required. So this is one of the major challenges. Next is heterogeneity. We all know that cloud-based IoT method has significant challenges due to enormous variety of platform, devices, services, and operating systems, etc. Cloud systems struggle with heterogeneity as well. For instance, most cloud services offer proprietary interface that permit resource integration based on particular suppliers. Next, we have the performance challenge. It takes a lot of bandwidth to send the massive amount of data generated by IoT device to the cloud. It is essential to have adequate network performance for sending data to cloud settings. In fact, since broadband development has lagged behind advancement in computing and storage. We have legal aspects. The significance of legal consideration has been brought to light by recent research on certain applications. For instance, service providers have to abide by numerous foreign laws. We have monitoring as well, which is for performance, resource management, capacity planning, security, SLAs, and troubleshooting. Monitoring is a crucial step in cloud computing, which needs to be handled as well. Finally, the new research initiatives that we have in our work. Future cloud computing system development will be increasingly influenced by big data and IoT. Application experiments, services, and simulations that enable the cases connected to big data and IoT are being demonstrated in research and commercial activities in the cloud. Now, a new set of issues and difficulties are brought about by the provision of aforementioned problem, which must be recognized and addressed at the earliest. There must be the gathering of scholars and practitioners to discuss numerous facets of security, privacy, and the various challenges that we have mentioned in the previous slide. And one more is the dependability in IoT and cloud, which is the major problem that needs a solution. So we are concluding our work that IoT is a new technology that is progressively becoming a part of many aspects of our life. As already mentioned before, we are using it in our day-to-day life like smartwatches, etc. So the limitations of IoT as stated in the paper should be taken into consideration. We must consider various issues and shortcomings in the present technical approaches, and a variety of case studies will also be conducted in future work to examine the efficacy of cloud-based IoT method in various domains. Here we have explored the challenges and issues and have elaborated, discussed to find the scope of future research directions via the review of previous paper as well. These are a few references from our work. So here we conclude our presentation and leaving for others to continue the work. Thanks for your time. Thank you.